Question 3. Resolve I plus 3j into rectangular components, one of which is parallel to 2i minus 2j. So I want the vector projection of A in the direction of B, where let's let vector A equal I plus 3j, B equal 2i minus 2j, and I want the vector projection of A on B. So that's the first part. So A on B, look at your formula sheet. The formula is vector A, well, the dot product of vector A and the unit vector times the unit vector of B. Replace this unit vector. So we have the dot product of A and B all over the magnitude of B. And then that's going to be multiplied by the unit vector of B. Find out what we need. So the dot product of A and B is going to be 1 times 2 plus 3 times negative 2, which is 2 minus 6, which is negative 4. Our magnitude of B is the square root of 2 squared plus negative 2 all squared. 4 plus 4 is 8, which we can simplify to 2 root 2. So that means my unit vector B is 1 over 2 root 2 times by vector B. Come back and plug everything in. So we've got negative 4 over 2 root 2, all outside of 1 over 2 root 2, times by 2i minus 2j. That becomes 2 root 2 times 2 root 2 is 8. So negative 4 over 8, 2i minus 2j, which ends up giving us negative I plus j. So that's the first part. Now I want the perpendicular component. I'm realizing I am not going to have enough room. But anyway, perpendicular component is the vector A minus what we found in the previous section. So this here is that. So that becomes I plus 3j minus negative I plus j, which gives us 2i plus 2j. So that means I can rewrite my A, my vector A, which equals I plus 3j, is the same as negative I plus j plus my 2i plus 2j. Now if you're struggling with understanding why, go back to that original kind of diagram. This is vector B and this is vector A. First part of the question we found A on B. Second part of the question we found the perpendicular component, so you can see why A is equal to the addition of those two. And I'll write those in so you can see what I mean. This is negative I plus j. and this here is 2i plus 2j. Now there was a second part of the question. It said one of which is parallel to 2i minus 2j. Now you'll notice 2i minus 2j can be rewritten as negative 2 negative I plus j this here is that part there. So it's parallel but in the opposite direction. So it's equal to some scalar k times by a on b. So that's why it's parallel.